Good day, students. Today we want to look at this stoichiometry question which came in February, March 2024. It was paper 42. It was a question whereby you were being asked to find the concentration of nitric acid in grams per dm cubed. Right, so it's like a typical base acid reaction. So whenever you get such questions, you find out that one of the solutions here will be a standard solution. By a standard solution, we are saying one of the solutions that you are given, you'll be knowing its exact concentration. Okay, right. So if you look at what is happening here, we have dilute nitric acid is reacting with a base, calcium hydroxide. Okay, and then we are given a reaction here. This reaction is very, very important because it guides you on the stoichiometry. It actually tells you the number of moles or the ratio or the molar quantities of each reactant. So it's very important for you to be able to use that equation. Okay, right. So we want to go step by step as indicated in the question so that at the end of the day, we are in a position to find the concentration of the unknown, which is nitric acid in this case. Right. So what do we do first? Whenever we are doing these calculations, maybe in some cases it comes with titration, always start with the standard solution. And our standard solution in this case is the base, which is calcium hydroxide. So we first of all find the number of moles of calcium hydroxide. So the formula that we are going to use here is the number of moles for number of moles is always equal to concentration times volume. It's very, very important for you students to remember that we have triangles that we can use to help us. Okay, I'll just draw this triangle by the side here. Okay, we have triangles that we can use in chemistry to help us to calculate these quantities. Okay, so the triangle that we're going to be using today is the NCV. Okay, triangle, whereby small letter N in chemistry refers to number of moles, and the small letter C refers to concentration, and small letter V refers to volume. Okay, and always our volume is supposed to be expressed as dm cubed. Okay, so this triangle is very, very important. And whenever you are answering your chemistry exam, make sure you draw these small triangles to allow you to remember the important formula that you're supposed to use. So we want to calculate number of moles of calcium hydroxide as indicated in our triangle there. So number of moles, okay. So number of moles here, and we're just going to say okay, number of moles. Number of moles would be equal to, okay, so we have our concentration, which is given as 0.00150. So we are going to have 0.0150, okay, and then we are going to multiply by the volume that we are given. But remember, your volume is always supposed to be expressed over 1,000 in order to change the cubic centimeters to dm cubed. So that would be that would be the that would be the working there. And then if you calculate, okay, if you calculate, your answer is going to be equal to 3, okay, times 10, okay, to be 3 times 10 to the power 4. Okay, these are the number of moles of your base, okay? So and the other one is simply saying now you have to determine the number of moles of nitric acid which reacts with the calcium hydroxide. This one you need to remember that the molar ratio is 2:1. Okay, if you take your nitric acid and your calcium hydroxide, the molar ratio there is 2:1. Okay, because it's 2:1, if I'm going to migrate from the calcium hydroxide to the nitric acid, I am simply going to multiply by 2. Okay, right. So I'm going to multiply by 2. So the number of moles here, number of moles is simply going to be, right. So here I'll write number, okay, number of moles, okay, is going to be equal to 2 times what we got before, because the molar ratio is 2:1. So times, okay, 3, all right, times 10 to the power 4. Okay, so that will be the working here. Okay, and then our answer, we multiply that one by 2, it will simply be 6 times 10 to the power minus 4. Okay, right. That will be our answer there. Okay, right. So we have actually calculated now the number of moles of nitric acid. Okay, now they're saying calculate the concentration. If you go here, you want to calculate concentration, right? So if you cover concentration, you're going to have N over V. So concentration will be N over V. All right, so your N is 6 times 10 to the power 4. Okay, so your concentration will be number of moles 6 times 10 to the power minus 4 over the volume, which is given here in the question, is given as 25. But remember, the 25 has to be converted to dm cubed. So how do you work it out? Okay, so we come here and then we write our concentration. The concentration, our concentration is going to be equal to, okay, the number of moles that we calculated at the top here times 10 to the power minus 4. Okay, now we are going to divide by the volume that we are given. Okay, the tricky part is you are given 25 there, please convert it to dm cubed, and you say 0.025. You don't divide by 25, because at the end of the day, if you are going to have your concentration in moles per dm cubed, you are supposed to convert the 25, okay, cubic centimeter, so that it becomes dm cubed. Otherwise, if you do that, you'll be calculating moles per cubic centimeter, which is not standard at all. So if you divide, you're going to get your answer here. Okay, your answer that you're going to get here will be, let me just check on my calculator again. That one is 6 times 10 to the power times 10 to the power minus 4 divided by, your answer that you're going to get here would be 0.0240. Okay, that would be your concentration. All right, so this is how we solve that one from the top right down to the bottom. Okay. Right. So I suppose there's another question which follows at the bottom there, whereby we are supposed now to change our concentration from moles per dm cubed to grams per dm cubed. That is very simple. We are changing, it's like we are changing the moles to mass. Okay. Once again, you need to remember the other triangle. I'm going to draw it here. Okay, there's this other triangle whereby we are also calculating number of moles. Okay, right. So there's another triangle which we also have to know. There's the NCV, and then there's also the one where we calculate number of moles. Our N is now by the side. Our small letter m is the mass given, and then we have our MR. Okay, right. So what we are now doing is, it's like we are changing our concentration to moles per dm cubed to grams per dm cubed. It's like we are finding M. Okay, so if you want to migrate from number of moles in concentration to mass in concentration, it's like we're just finding M. And if you are finding M, it's going to be NMR. So we need to find the the MR for nitric acid, the MR for nitric acid, and then we can migrate from moles per dm cubed to grams per dm cubed. I suppose everything else is clear here, because I just want to remove the annotations. Okay, right. So I'm removing the annotations, and then I want to migrate a bit down so that we can answer the last question. Okay, right. So the last question is now referring to the conversion of concentration from moles dm cubed to concentration in grams per dm cubed. Like I said, it's like you are changing the moles to mass. All you simply do is you simply take your previous answer, which we got before, our previous answer in moles per dm cubed. If you still remember, we got a 0.024. Okay, and then if we check the MR for nitric acid is 68. Okay, so we multiply that, sorry, 63, not 68, 63. Okay, we multiply that by 63, and then when we do that, our concentration will simply change to, it has simply changed our concentration from moles per dm cubed to grams per dm cubed, and then our answer here will be 1.51. I'm also getting 1.512 on my calculator. I'll just give it as 1.51 grams per dm cubed. Okay, so that's how we can solve the stoichiometry. Always start with the standard solution. Stage number 2, look at the stoichiometry in the equation. Migrate from the standard solution to the unknown, and then you calculate the concentration of the unknown. If they want the concentration now in grams per dm cubed, you simply multiply by the MR, and then your concentration expression changes from moles per dm cubed to grams per dm cubed. Thank you, students, for listening. Bye-bye for now.